All right, so our last topic for this unit is solving equations with rational exponents. Okay, so rational meaning can be written as a fraction, okay, and then exponents, you know what exponents are. So as you look at all these, you're gonna notice that they always have fraction exponents in them, okay? So we're gonna solve equations that have these rational exponents, and the trick that we're going to use to do this is we're gonna raise both sides of the equation to the reciprocal power. Okay, now a reciprocal, when we're talking fractions, is basically the flip. Okay, so like 3 over 5 and 5 over 3 are reciprocals. Okay, one is like the flip upside down of the other. Okay, so like when we look at this guy here, what I'm going to do is I have this 1/2, 1 over 2 power. So what I'm going to do is I'm going to raise both sides to the 2 over 1 power, right? So 1/2 and 2 over 1 are inverses. And the way that that's nice is because we can now use the power to power rule, right? If you remember the power to power rule, that says that if you have something like x squared to the third power, right? That means that you're doing x squared times x squared times x squared, which is x to the sixth. So the shortcut is that you can multiply, if they're power to power, you multiply your exponents to get your simplified answer, right? So on this guy, we can multiply 1/2 times 2 over 1, which is just 1, right? So it essentially cancels out that exponent and leaves me with just x minus 2. And then on this side, well, 2 over 1 is just 2, so that's just 9 squared, right? So that equals 81, right? And then I can solve that, get x equals 83. Okay, you do want to make sure that you check your solution, right? Make sure it's not extraneous. So 83 minus 2 raised to the 1/2 power. We want to know, does that equal 9? Well, that's 81 to the 1/2 power, which is indeed 9. Excellent, right? Because 1/2 power, that's a square root of 81. All right, cool. So let's look at this next guy. So this one, before we raise to the reciprocal power, we want to isolate that exponent. So I'm going to start by subtracting the 5 on both sides. Okay, and that'll be equal to 3. Okay, and then what my step is going to be is I'm going to raise both sides to the 3 over 1 power. That's the reciprocal of 1 over 3. So on this side, 1/3 times 3 over 1 cancels out to 1. So that leaves me with just x plus 4 to the first power. And over here, 3 to the third power is 27. So x equals 23. Okay, again, we just want to check it. So that's going to be 23 plus 4 to the 1/3 power plus 5. Does that equal 8? Well, 23 plus 4 is 27. And to the 1/3 power, right, power over root, that's like the cube root of 27. So the cube root of 27 is 3. 3 plus 5 does indeed equal 8. So we're all set. All right, this guy over here. So first thing I'm going to do, reciprocal power. So I'm raising this to the 2 over 3. So on the left side, 3/2 times 2 over 3 cancels to 1. So that's 2x minus 3. And then 8 to the 2/3 power. I'm going to have to simplify that. So 8 to the 2/3 power, remember power over root? So it's power over root, right? So the cube root of 8 is 2, and then 2 squared is 4. So that's 4. Okay, so add 3 to both sides. 2x equals 7. So x is 7/2. Okay, and then just go back, double check that answer, right? So 2 times 7 over 2 minus 3 raised to the 3/2 power. We want to know, does that equal 8? Well, 2 times 7 over 2 would just be 7. 7 minus 3 is 4. So 4 to the 3/2 power, right? Is that 8? Well, 4 to the 3/2 power over root. So we take the square root of 4, which is 2, raise it to the third power, which is indeed 8. So that worked. All right, this guy here, we're raising something to a negative exponent. So again, same deal. I'm going to raise this to the negative 2 over 1. Right? That's the flip of negative 1 over 2. So on this side, those cancel to positive 1. And on this side, 1/5 to the negative 2 power. right? So negative exponents flip things. So this is the same thing as, so we're looking at 1/5 to the -2 power. That's the same as flip the 1/5 to 5. It's the same thing as 5 squared. So 25. Okay, add 4 to both sides, so x equals 29. When I go to check this, right, I'm going to do 29 minus 4 to the -1/2. We want to know if that equals equals 1/5, excuse me. So 29 minus 5 is 25. Okay, so then 25 to the 1/2 we know would be 5, and the negative tells you to flip, so 1/5. So we're still good. All right, lovely. And then our last example down here. So this one, I'm going to raise both sides to the 3/2 power. 2/3 times 3/2 cancels to 1. And then 25 to the 3/2 power. So 25 power over root, right? So power over root. So the square root of 25 would be 5. 5 to the 3rd power is 125. So 2x equals 126. So x equals 63. And then we're going to check that. So 2 times 63 minus 1, right, raised to the 2/3 power. Does that equal 25? So 2 times 63, 126, right, minus 1, 125. So 125 to the 2/3 power. So 125 power over root. So the cube root of 125 squared, yeah, that'll work out, right? Cube root of 125 is 5. 5 squared is 25. So that does indeed work out, and our answer is just 63. Okay, so solving with fractional exponents, not too hard. You just have to sometimes do a little scratch work on the side to simplify some radicals. And remember, it's always just the reciprocal. You don't change the signs. Okay, I know that was something that always threw me off when I was in high school. When you find a reciprocal, you don't change the sign of the number. It's just straight up the flip. Okay, so you just flip them, you leave the sign the same. And that's how you solve equations that have fraction exponents in them.